Okay, all these problems are related rates, so that means we need to use implicit differentiation to solve. Because we're asking about the area of a circle, we're going to use the equation a equals pi r squared. And you have to read the problem carefully. It says the radius is increasing at a rate of 1 foot per second. So that means the change in radius over the change in time is 1. The radius itself is 4, and we are looking for the rate, the change in area, the rate of the area over time. So using implicit differentiation to solve, or to take the derivative to find all the different rates, and then we're going to plug in all the answers we know. The radius is 4, and dr dt is 1, so we get 8 pi feet squared per second. Now for number 2, that we have the equation. X is units, so 500 units is X. Sales are increasing at a rate of 10 units per day. So that means dx dt is 10. And we want to find the rate of change in the profit, so dp dt. So we need the derivative of our original equation. I'm going to plug in everything I know. I'm going to reduce 2 over 4 to 1/2. X is 500, and dx dt is 10. Oh, I made a mistake. When I differentiated the 500 here, I forgot to take the derivative of the x, dx dt. So now it's 500 times 10 minus 1/2 510. So simplifying all of that, 500 times 10 is 5,000 minus 2,500. So our answer is $2,500 per day. Okay, we have a sphere being inflated at a rate of 10 pi cubic feet. So that's a volume. So this is the formula for the volume of a sphere. dv dt is 10 pi. Radius is 2, and we're looking for dr dt. What is the change in radius? So dv dt, 3 times 4/3 is 4. Now I'm going to plug in everything I know. And start to simplify. So 4 times 4 is 16 pi. We're going to divide both sides by 16 pi. And our answer, dr dt, 10 over 16, that reduces. We can reduce both by 2, so that would be 5/8, and it is feet per second. Okay, for number 4, here's my building with a ladder. The ladder's a fixed length of 25 feet. I'm going to call this side X and this side Y. It's being pulled away from the bottom of the wall at a rate of 15 feet per second. So that means the change in x over the change in time is 14. At what rate is the top of the ladder moving down? So we need to find dy dt when the ladder's 7 feet. So y is 7. Well, we can use Pythagorean theorem to solve for x. And we get x is 24. Now I'm going to go back to Pythagorean theorem and use that to find the derivative. And I can divide everything by 2 if I want. So I'm going to do that as I plug in my values. So x is 24. And I'll leave the 2. We have a calculator. Dx dt is 14. Y is 7. Dy dt is what I need to find. So now we can multiply this together, multiply these together. We get 672 plus 14 dy dt equals 0. So now solving, I'm going to subtract 672. We're left with 14 dy dt equals negative 672. Divide by 14. And our answer is negative 48, those cancel, and it is feet per second. Now this negative makes sense because it's moving down, in the down direction is negative. Okay, so now for the 5 classwork and homework problems. The answers are all at the bottom of your page, and I will demonstrate all the A parts of these problems. So we have a circle. We're looking at the area. A equals pi r squared. So we're going to find the derivative with respect to time and plug in everything we know. It says the radius is increasing at a rate of 2 inches per minute. Well, that's dr dt. And for part A, the radius is 6. So when I do 2 times 6 times 2, that's 24 pi, and it is inches squared per minute. For number 2, we have the volume of a sphere. So we're going to find the derivative. And plug in. So if the balloon is inflated with gas at a rate of 20 cubic feet per minute, cubic feet is the unit you would use for a volume. So I know that 20 is dV dt. For part A, the radius is 1. And dr dt is what we need to find. So we have 20 equals 4 pi dr dt. I'm going to divide both sides by 4 pi. We can reduce this by 4, so we get 5 over pi feet per minute. Okay, if costs are increasing at a rate of $125 per week, that means, well, costs are x, so dx dt is 125. The costs themselves are $1,500, so x is 1,500. And now we're going to take the derivative of our equation. ds dt is 50 dx dt this. Now 2 times 0.35 is 0.7 x dx dt. And we want to find the rate of change in sales, so that's solving for ds dt. So I'm plugging in all the values that I pulled out of the word problem. And we get the change in sales over the change in time to be $137,500 per week. Okay, so for number 4, we have a cube, and the edges are expanding at a rate of 3 centimeters per second. Well, if I have a cube, I'm going to call each side x, so the volume is x to the third. Well, if the edges are expanding at 3 centimeters per second, dx dt is 3. How fast is the volume? That means we need to solve for dv dt. So for part A, 1 is the length of my side, 3 is my rate of change. So 3 times 3 is 9, and it's a volume, so it is centimeters cubed per second. And I'll do part A for number 5. 25. You know what? A is the same values that we did on the first number 4, so I'll do B. I'm going to call this Y and this X. So for part B, the base is 15 feet from the bottom. So if I find what y is, 15 squared plus y squared equals 25 squared. We have to use the Pythagorean theorem. We're going to solve this, and we get y is 20. So again, back to Pythagorean theorem. Find my derivative. And now plug in what we know. X is 15. The ladder is being pulled away from the house at a rate of 2 feet per second. So for all these parts, A, B, and C, dx dt is 2. We need to solve for dy dt. So 2 times 15 times 2 is 60. I'm going to subtract 60 over. Divide by 40. And we get for part B here, dy dt is negative, because it's going down, 3/2 feet per second.